Okay, let's give you guys some more practice. So sketch this function here. As a clue, don't always follow the same routine. Meaning when you draw your graph, don't always follow the same routine where, oh, let's investigate what happens when x is really big, when x is really negatively big. Don't always follow that routine, because in this case here, look what's happening. When you look at this, visualize the natural log of x. So the graph will look like this, and then what you put into the x here is the sine of x here. So visualize the sine of x here. You see what goes, if you look at this natural log of x, what goes in here, it really oscillates between positive 1 and negative 1. What goes into here is really, it oscillates between positive 1 and negative 1. So because you've got a sine of x, it oscillates back and forth. So try and when you look at this, visualize the natural log of x here. But then just know that this x here jumps from positive, and then negative. Then when it's in this realm here, when it's in this realm here, it's meaningless, because what is the natural log of a negative number? Is undefined in the negative realm. So think about it. Try and guess to see what this graph will look like. Anyway, press pause and have a go. Okay, so to do this here, yeah, you use the same argument here. So this thing here, so basically, when you look at this here, in your mind, visualize this graph here, and then this thing here, visualize sine of x. So if you think about it, as you draw your graph like this, as you draw your actual graph, it goes from 0 to infinity here. As you draw your graph, look what happens. Well, you know that the natural log of x looks like this. Now, sine of x is going to be between 0 and pi here. It's going to be positive, meaning it's going to be, when you put it into here, it's going to be valid, and then here invalid. So you know. Well, you know it's going to be periodic, meaning that hang on, look at this here. So you draw something like this. Okay, hang on, bear with me. So this thing here, between here and here is valid, and then in between here and here is invalid. So when you draw your actual graph, it's not really valid in this region. This is valid. This here would not be valid here. Okay, it's not valid here, because so this bit here, hang on, so this bit here, from here to here, is good. It's in this region here, so it's defined. But here to here is undefined. So forget about this bit of the graph. And then from here to here is valid again. So it's valid again in this region here. And then from here to here is not valid. So forget about this region. Okay, so overall your graph will look something like that. But you do, but hang on. So looking back at this here, you've got the natural log, and you've got the sine of x here. So what goes in here oscillates between well, 0, well, 0 and a bit, well, increasing to 1, and then it's starting to decrease. My point is that here it's going to be pi over 2. Okay, so when it's at pi over 2, this will be 1. Well, when x, when you look at this graph here, when you put pi over 2, that will be at this point here. You can see that at this point here it is 1. Okay, pi over 2 sine of x will be 1. Now if you put 1 into here, the natural log of 1 is 0. So overall the natural log of 1 will be 0. So this whole thing here will be 0. Okay, so that means your graph is going to cross somewhere around here. Okay, and then you know dead on pi, which is 0, dead on pi here, it breaks down. Dead on pi sine of x would be 0, and then when you put this into here, it breaks down. Remember, natural log of x, where x has to be greater than 0. So if you try and put 0 into here, it breaks down. My point is that here, dead on pi here, if you try and put sine pi into here, this whole thing here breaks down. So you know something weird happens dead on pi. So you can do this. Okay, and then now let's look. Just hang on. You know it breaks down when it's dead on pi. Look what happens when it's look what happens when it's just to the left, just to the right of 0, and then also investigate what happens just to the left of pi. Meaning, well, just to the right of 0. Let's put in 0.00001. Okay, put 0.001 into here. So this here, well, looking at the sine graph, it would be a tiny number. So now put this tiny number into here, and then that would be also a tiny number over here. So this bit here, the natural log of a tiny number would be negatively massive. Would be somewhere down here. Okay, and let me just repeat that. So hang on. So when investigate what happens when you're just to the right of the 0, because it breaks down dead on 0. So so look at a number just to the right of 0. Okay, let's put in this thing here. Put this thing into the sine of x, and then that will translate somewhere around here, which is also a tiny number, which happens to also be a tiny number. Now put this overall tiny number into here, and then that will be somewhere around here, and then that will then jump to somewhere down here. You see overall it's going to be a very, very big negative number, because you can see natural log negative number. So it's going to be a very big negative number. So overall it will be this, and then it would touch at 0, and then you can use the same argument for just to the left of pi, and then it's going to go down again like this. Because if you think about it, hang on, if you think about it, this one here goes up to 1 and then back down. So what's happening on this thing is it's moving like this. It's moving. It starts from here, and then it moves to 1, which will be at this point here. And then when you start to move down here, it starts to move back here. So as sine of x oscillates like this, what it's doing to the natural log graph is this: up here and then back down here, and then you have to wait a while, waiting a while. Now it's back to valid. It will do this again, from here up here, and then back again, and then invalid. So you got to wait, and then it will go back up, and then back down again, and then wait, and then back up again, and then back down again. Okay, so overall your graph will look something like this. Overall your graph will look something like this. This is pi over 2. So it will look something like this. Okay, and then something like this, and then something like this. Okay, in the next video we will look at the first and second derivatives. Okay.